Good day, everyone. Today, our group will discuss a topic titled The Rate of a Reaction and the Various Factors that Influence It and the Collision Theory. Now, let's move on to the first topic, which is the collision theory. Collision theory explains why different reactions occur at different rates and suggests ways to change the rate of a reaction. Collision theory is one of the fundamental foundation or key factor that we should take note of with regards to observing how a reaction takes place between two different particles or reactant. Reaction rates may vary depending on the collision that happened between two particles. Collision theory states that for a chemical reaction to occur, the reacting particles must collide with one another. The theory also tells us that reacting particles often collide without reacting. For collisions to be successful, reacting particles must collide with sufficient energy and with the proper orientation. Next, with regards to this theory of collision, it has been emphasized that collision itself isn't sufficient for a successful reaction to occur. Various factors that might influence the rate of the reaction must be considered, and these are the positive collision of two particles, sufficient energy, and proper orientation. As stated in the collision theory, reaction between two particles can be successful if that collision that has happened has been effective. Two particles or reactant may collide with one another, but the possibility of collision being an effective one isn't 100% sure. Collision theory assesses diverse range of external and internal influence that may affect the rate of collision to undergo evaluation if two particles can produce an effective rate if collision. Collision theory states that number one is molecules must collide before they can react. The second is not all collisions are equal. The third is unimolecular processes also begin with a collision. According to the collision theory, we can all infer that collision of two particles are necessary and significantly important as needed for a reaction to occur. Basically, if there is no collision, reaction between two particles won't be applicable. Collision theory significantly emphasizes the key influence of particles colliding to create a reaction. As stated by collision theory, not all collisions are equal. This means that the rate of reaction produced from the collision may vary depending on the influence of other factors that can affect the collision and reaction process between two particles or reactants. In collision theory, the factors that increase the rate of a reaction must influence at least one of the following. The first is how often collisions occur. More frequent collisions will mean a faster rate. The second is more effective collisions in terms of collisions occurring with sufficient energy. And the third is more effective collisions in terms of collisions occurring with the proper orientation. Based on this context of collision theory, this integrates the concept of the more molecules that are present or in the process of reacting with other molecules, the more collisions that will happen. In accordance to this theory, one must take note of a key idea that molecules must collide before they can react. Collision before reaction. If there is no collision, there is no reaction. Furthermore, as stated by the collision theory, to effectively initiate a reaction, collisions must be sufficiently energetic to create or bring about this bond disruption. In simple words, collision theory is all about two molecules or particles colliding. And if there is a successful collision, there will always be a reaction or a product that will occur. As a recap, and for you to remember, collision theory provides an explanation for how particles interact to cause a reaction in the formation of new products. In addition, according to the collision theory, the following criteria must be met in order for a chemical reaction to occur. The first is molecules must collide with sufficient energy, which is known as the activation energy, so that chemical bonds can break. The second is molecules must collide with the proper orientation. And lastly, a collision meets these two criteria. And that results in a chemical reaction, which is known as a successful collision or an effective collision.
Today I'm going to discuss the rates of chemical reaction. By definition, it is the speed at which the reactants has turned into products. There are various rates of reactions. For a slow reaction rate, such as the rusting of iron, which can take years or maybe even decades, a more typical rate is something like the reaction of magnesium and an acid, which produces hydrogen bubbles. Then there are extremely fast rates, where an example is a fireworks explosion, which can happen within a split second. There are two ways to measure reaction rates. The first one is how fast the reactants are being used, by dividing the quantity of the products used over the time it took for that change to occur. The second one is how fast the products are formed. Reaction rate, which is equal to the quantity of products formed over the time it took. An example is when the magnesium and an acid reaction produces 180 cubic centimeters of hydrogen gas in 2 minutes. The first thing to do is convert 2 minutes into seconds, giving 120 seconds. By dividing 180 cubic centimeters into 120 seconds, this will give us a reaction rate of 1.5 cubic centimeters per second. Alternatively, if we were given 3 grams of magnesium and say that it held for 4 minutes before completely dissolving, then we could use the other equation and use 3 grams divided by 4 minutes or 240 seconds, which give us 0.0125 grams per second. Keep in mind that the given examples were the average or mean rate of chemical reactions. In reality, the reaction would start off as really fast as there are many reactants that can react together, but gradually slows down as the reaction progresses while the reactants are all used up. Shown in the graph is the time on the x-axis and the mass of reactants and volume of product formed on the y-axis. As for the mass of reactants, which would start at 3 grams and at first would fall quite rapidly, but then would slow down as the reaction progresses because it gets used up less quickly. Meanwhile, for the other graph, we know that at the beginning we have no product, so it starts at 0. However, it quickly increases as lots of hydrogen are produced at the beginning of the reaction. Then as the reaction progresses, the graph finally starts to be in a straight horizontal line as we run out of the magnesium.
There are factors that affect the rate and how they influence it, but there are 4 specific ones that will be explained by my fellow groupmates. They are reactant concentration, physical state of the reactants of surface area, temperature, and presence of a catalyst.
So, diba, sabi sa collision theory that in order for particles to react, they have to collide with each other with sufficient energy, or also known as the activation energy. Magdedepend ang rate at a given point on two main things. First is the amount of energy that the particles have. The more energy they have, the more energy they can transfer during the collision. So the more likely they are to surpass the minimum activation energy. Next is the frequency of the collisions. This is how often the particles collide with each other. The more often they collide, the more successful collisions there will be overall. So, para malaman kung paano naka-affect itong 4 na factors sa rate ng reaction, we need to think how they affect the amount of energy that the particles have and the frequency of the collisions, kasi increasing either of the two will increase the rate of reaction. So, punta na tayo sa number 1. Reactant concentration, this is for solutions, and reactant pressure para sa gases. This is how many particles there are per unit volume. Increasing the concentration of one or more reactants will often increase the rate of reaction. This occurs because a higher concentration of a reactant will lead to more collisions of that reactant in a specific time period. So, pag mas mataas daw ang concentration ng particles, mas maraming collisions ang mangyayari. Ito yung sa number 2 kanina, yung frequency of the collisions. Kapag mas mataas ang frequency of collisions, mas mataas ang rate ng reaction.
Physical state of the reactants and the surface area. If reactant molecules exist in different phases, as in a heterogeneous mixture, the rate of reaction will be limited by the surface area of the phases that are in contact. For example, if a solid metal reactant and gas reactant are mixed, only the molecules present on the surface of the metal are able to collide with the gas molecules. Therefore, increasing the surface area of the metal by pounding it flat or cutting it into many pieces will increase its reaction rate. The rate of reaction between two molecules or particles aren't just simply reacting with one another with no other factors influencing the rate of reaction. To build up an effective and success reaction with two molecules, observing and determining the appropriate physical state and surface area are significantly beneficial and can serve as a basis of guide to minimize the occurrence of failed reactions. Understanding the factors that affect the reaction rate, like the case of physical state and surface area, are all fundamental and critical for two molecules to attain a successful rate of reaction with one another. Physical state refers to the state of the molecules in solid, liquid, or gaseous phase. If two different molecules are subjected into forming a reaction and the two aren't compatible, expecting a successful reaction isn't applicable. Checking the physical state and the compatibility of two molecules must be assessed in order to form an effective reaction. In terms of surface area, if two molecules are in a closed tight space and they don't have the freedom to collide and react with one another comfortably, this can also affect the rate of reaction. Too big or too small surface area are a factor to consider in the reaction process of two molecules. Compared with the reaction rate for large solid particles, the rate for smaller particles will be greater because the surface area in contact with the other reactant phase is greater. If the surface area of a reactant is increased, more particles are exposed to the other reactant. There is a greater chance of particles colliding, which leads to more successful collisions per second. The rate of reaction increase. This stated statement here refers to the vital influence of surface area in the reaction rate process of two reactants. To simply put, if two large solid particles are put together and expected to collide with one another, the speed or rate of reaction will be slow and the possibility of obtaining a successful reaction is low. Compared to the smaller molecules that has been expected to collide with one another, and this has the higher probability to anticipate an effective collision and reaction. The rate of reaction of a solid substance is related to its surface area. In a reaction between a solid and an aqueous, liquid, or gas species, increasing the surface area of the solid phase reactant, and it increases the number of collisions per second, and therefore it increases the reaction rate. Basically, to conclude about the influence of the surface area in the rate of reaction, increasing the surface area of a reactant increases the frequency of collisions and increases the reaction rate. Several smaller particles have more surface area than one large particle. The more surface area that is available for particles to collide, the faster the reaction will occur.
As the temperature of a reaction increases, the particles gain more energy, which results on the particles moves faster and can trigger them to collide more frequently. The particles collide with more energy as the temperature increases, which will more likely exceed activation energy. So in conclusion, there will be a higher rate of successful collision and thus a higher rate reaction.
As for the last factor that we need to cover is the presence of the catalyst. Catalysts are substances that speeds up a reaction without being used up in the reaction themselves. So that's why we don't include them in the reaction equation, as they're not reactants of products. As you can see, there is an image attached on the right side. We will use the reaction profile to understand how the catalyst works. The reaction profile shows the change in the chemical's energy during a reaction. The distance between the reactant's energy level and the very top of the curve is the activation energy. Activation energy is the energy required for the reaction to take place successfully. What the catalyst does is that it lowers the activation energy by giving the system an alternative pathway, and this means there will be a higher proportion of successful collisions. So that's all for the factors that affect the rate of reactions. As for the next slide, we will be talking about activation energy and catalyst. So what is activation energy? Activation energy is the minimum amount of energy required for the reaction to occur. It is also known as the energy barrier because if there's not enough energy, the reaction won't occur. Activation energy can also be abbreviated as E sub A. As you can see, the picture below shows two potential energy diagrams, an exothermic and endothermic reaction. In an exothermic reaction, the product sits lower and it releases energy. And for the endothermic reaction, the product sits higher and it needs to absorb energy to occur. For the next slide, for the catalyst, it provides an alternative pathway for the reaction to occur. It decreases the amount of energy needed for the reaction. It also speeds up a reaction without being used up in the reaction themselves. Catalyst does not get consumed in the reaction at all. As for the image that is attached on the left side, you see an endothermic reaction diagram with and without the catalyst. What the catalyst does in this reaction is that it lowers the activation energy by giving the system an alternative pathway. That's all for the activation energy and catalyst. As for the different types of catalyst, Mr. Nico Logroño will discuss it.
Again, catalysts are chemical compounds that increase the rate of a reaction by lowering the activation energy required to reach the transition state. Unlike reactants, a catalyst is not consumed as part of the reaction process. Ang catalysis is the process of speeding up a reaction by using a catalyst. Moving on to the types of catalyst, we have heterogeneous catalyst, or also known as the surface catalyst. Heterogeneous catalysis is a type of catalysis in which the catalyst occupies a different phase than the reactants or reaction mixture. Halimbawa, liquid yung reactants, pero yung ginamit na catalyst is in solid form, pero yung kinalabasan or yung product or yung reaction mixture is still in liquid form. Dito, naiiba lang yung phase ng catalyst sa phase ng reactants and ng reaction mixture. Generally, heterogeneous catalysts are solid compounds that are added to liquid or gas reaction mixtures. In heterogeneous catalysis, the reactants adsorb. Ano nga bang adsorb? Pag sinabi nating adsorb, it is the adhesion or yung pagdikit-dikit, yung pagstick. The reactants adsorb onto binding sites on the surface of the catalyst, and the availability of these reaction sites can limit the rate of heterogeneous reactions. So, sa image, makikita ang kulay blue, yan yung catalyst, which is an iron. Tapos, yung H2 and yung N2 are the reactants. So, nag-approach sila, nag-stick sila sa surface ng catalyst, tapos, reaction takes place and new bonds are formed. Tapos, aalis na sila para makapag-catalyze pa yung catalyst ng ibang reaction. Next is the homogeneous catalyst. Homogeneous catalysis is a type of catalysis in which the catalyst occupies the same phase as the reactants or reaction mixture. So, dito naman, kapag liquid yung reactants, yung gagamitin na catalyst is in the liquid form, tapos yung product or yung reaction mixture is liquid form din. So, lahat sila same phase. Homogeneous catalysts allow for greater interaction with the reaction mixture than heterogeneous catalysts. The last type of catalyst is the biocatalyst, or also known as enzymes. Enzymes are a special class of catalysts that can accelerate biochemical reactions. So kaya siya tinawag na biocatalyst is because enzymes catalyzes biochemical reactions. Biocatalyst. Enzymes are proteins that bind reactants or substrates in regions called active sites. So bago tayo mag-proceed sa process, alamin muna natin yung meaning ng words. Substrate, the reactant or reactants involved in a biochemical reaction catalyzed by an enzyme. Enzyme, a protein that catalyzes a biochemical reaction. Active site, this is the area within an enzyme where the substrate binds. So, yung process. An enzyme catalyzes a biochemical reaction by binding a substrate at the site. After the reaction has proceeded, the products are released and the enzyme can catalyze further reactions. So, yung kulay gray, yan yung enzyme, and yung lubong, yung mga luho, ang tinatawag na active site. Tapos yung kulay green, sila yung reactants. Magbabind sila sa active site. Tapos pagkatapos nila makatalyze is maghiwalay na sila. Tapos aalis na sila sa active site para makapag-catalyze na ulit ng bagong reactants ang enzyme.
Hello, I'm Mr. Carte, and I will be explaining the three orders of the reaction rate. The first order that will be explained is the zero order. A zero order reaction, unlike the other orders of reaction, has a rate that is independent on its reactant concentration, or S. As a result, increasing or decreasing the concentration of the reacting species has no effect on the reaction rate. As the image has shown, these are the graph that would be explained for how the reaction rate and the zero order would affect each other. Next is the first order. A first order reaction can be defined as a chemical reaction in within the reaction rate is linearly dependent on the concentration of only one reactant. In other words, a first order reaction is a chemical reaction in which the rate varies based on the changes and the concentration of only one of the reactants. As shown on the image, it is also the graph that will be shown. Last one is the second order. Second order reactions can be defined as chemical reactions wherein the sum of the exponents in the corresponding rate of law of the chemicals is equal to 2. Here is a graph or a diagram that can show differences of the three orders. First order has the rate of law equals rate equals K. As for the first order, is rate equals K to A. Rate equals K, A squared, or A reactant A, reactant B. For the graph, as shown of the different graphs that have been mentioned. And these are the integrated rate laws that would be explained further. Thank you.